So let me talk about this example. Find the solution of this dy over dx equals to that. So this is called differential equation. Why is that? Because this has a derivative. If an equation has a derivative, then we call that as differential equation. So how do I find out the solution? Solution of a differential equation is the value of y. The derivative is given, you want to find out the value of y. How do I find? You integrate on both sides, right? So when you integrate, you will get y equals to, you get integral of 18 minus 9x squared over under the root x cubed minus 6x plus 4. And there is dx. When you integrate, that's what you get. Okay? Now what should be u? Tell me. You're right. That thing under the root must be u. Let's say let x cubed minus 6x plus 4 equals to u. So I set that as u. Now what happens to this term and dx? Let's find out the derivative. Then the derivative is 3x squared minus 6 dx. You see that? Equals to du. I find out the differential of u, right? So that will be du is f, this, the derivative of that times dx. Now what do I need here? I need 18 minus 9x squared, but what I got here, 3x squared minus 6. What should I do here to get 18 minus 9x squared? So I need to multiply both sides by what? I need to multiply both sides by times negative 3, right? Times negative 3. If I do that, what do I get is negative 9x squared plus 18x and then times dx, right? Will be negative 3 du. You see that? So instead of that quantity on the top, the whole with dx, you can add negative 3 du. So this can be written as, let's do that. This can be written as y is equals to, I would write this as y is equals to, let me write that integral is negative 3 du for the whole thing, right? And in the denominator there is root under u. So how do I write that? Let me pull that negative 3 out and then let me move that to the top, u to the negative 1/2. You see that? Because root u is u to the 1/2 and then du. So what happens to this? Just find out the integral. Negative 3 u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c, right? So what do you get? Negative 3. And this will be 1/2, right? This quantity is 1/2. So that is positive 1/2. But it is in the denominator. So this will, if you write the times reciprocal, that will be negative 6. And then u to the positive 1/2, right? That's what you get. So plus c is there. So now plug in the value of u. What is our u? U is that quantity, right? That is the u. So let me plug in that. Negative 6. And then write down that. You can write in the root form because that is the square root. 1/2 is the square root. So x to the cubed minus 6x plus 4, right? And then that is that. And then root is the 1/2 is, root is for 1/2. By the way, this root is like this. So this is not the 6th root, okay? So this is 6 times that thing. So and then plus c. Plus c. This is what you get as the final answer for this problem. Okay, let us see some more examples, okay? So on this example, I want you to find out the integral of sine 5x dx, okay? So how do I find out this? Is what you do is, what should be u again? We know what is the integral of sine x only, but there is, if there is some number times x, we don't know that formula yet, right? So what do I do is, I want to set that as u, okay? So set, so u equals to 5x. So now you find out the derivative, you will get du over dx equals to 5, right? This implies du equals to 5 dx, right? So but we need to find out, so this will be like sine u and then we need to find out the value of dx. So what is dx? Dx is 1/5. So divide by 5 on both sides. So you'll get dx equals to 1/5 du. That's what you get, right? Now let us plug into the integral. So the I is the integral equals to sine u times dx is 1/5 du. You see that? So you pull that 1/5 out, 1/5, and then integral of sine u du. What is the integral of sine? So negative cosine, right? Because the derivative of negative cosine is positive sine. So 1/5, and then you do negative cosine of u plus c. You see that? So what is the final answer then? It will be 1/5, and then minus 1/5, right? Negative 1/5 cosine of 5x. I plug in back the value of u, and then plus c. That is the final answer. How about this one? What should be u? So here I am taking u equals to 1/theta, because that we don't know what is the integral of cosine 1/theta, right? That's why I'm setting that as u. So set 1/theta equals to u. Now find out the derivative. What is the derivative of 1/theta? You do theta to the -1 equals to u, right? Now find out the derivative. You will get -1 theta to the -2 equals to du over d theta. I'm finding with respect to theta, not with respect to x, because there is theta there. So what you get is, this implies -1/theta square times d theta equals to du. You see that? But what do I need? I need 1/theta square and d theta. So I don't need that negative sign. So I divide by -1 or multiply by -1. So what do I get is, therefore 1/theta square d theta can be written as negative du. You see that? So it will be like cosine u, and then that thing will be negative du. So I'm assuming the whole thing as integral I is equals to integral of cosine u times and then negative du. That will be negative integral of cosine of u du. What is the integral of cosine u? It is, there is minus sign already, so negative sign, so sine u, right? Because the derivative of sine u is cosine u, and then plus c. Now plug in the value of u, negative sine and 1/theta. You see that? And then plus c. That's what it looks like. So let us do some more examples on the integration by substitution. Okay, so can you guess what should be substituted as u? Is that secant or the tangent? I would say tangent. Why is that? Because the tangent is inside the root. You see that? So let's do tangent 5x equals to u. Let's say u equals to tangent 5x, right? Now we need to find out the du, right? So what will be du? Du will be this derivative of that and then times dx, right? What this is like tangent u, kind of. Do you remember the chain rule? It is like tangent u. So what will be the derivative? It will be like, when you do the du is secant square, u is 5x, right? You can say, and then times that 5, right? And then there is dx. So it is f prime times dx, that is dy, right? It's like that. So u equals to tangent 5x. So du is secant square 5x times 5 and then dx, right? So but what do I need is, I will need the value of secant square 5x times dx only, because this will be u. This, I want to write this in terms of u as well. So this 5 is extra, so I want to divide by 5. So what do I get is, what this implies 1/5 du is equals to secant squared 5x times dx. You see that? So this is the value of secant squared 5x times dx is 1/5 du, and this will be u to the root 7th root of u, right? So that will be, therefore let's write down I, the whole integral I denote by I, is equals to, I would write 7th root of u and then times 1/5 du, right? This can be written as 1/5. I can write outside, so it is u to the 1/7 and then du. You see that? So 1/5. What is the integral of u to the 1/7? U to the 1/7 plus 1/1/5 1 7 plus 1, right? So this can be written as, this is equals to 1/5 u to the, so 8/7, right? Because there is like, this is 1/7, this is 7/7, so 7 plus 1, 8/7 over 8/7. Now plus c, right? I should not forget that constant of integration as a c. So how do I write this? This is like 1/5 times, you need to write the reciprocal of that, 7/8, and then u to the 8/7 plus c. So the final answer is, 7/8 times 5 is 40. And what is the value of u? U is tangent 5x, right? Tangent 8/7 and then 5x plus c. That is the final answer.